Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try out a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/Linode today, that's Linode, and get a $60 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. You listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For more opportunities to stay up to date, gain new skills, and learn from your peers, there are a growing number of virtual events that you can attend from the comfort and safety of your own home. Go to pythonpodcast.com/conferences to check out the upcoming events being offered by our partners and get registered today. Your host, as usual, is Tobias Macy, and today I'm interviewing Igor Dejanović about textX, a meta language for building domain-specific languages in Python. So, Igor, can you start by introducing yourself?
Hi, Tobias. Thanks for having me. Sure. I'm Igor Dejanović. I work as a professor at the University of Novi Sad, teaching there several courses in software engineering. And the most relevant for this podcast is probably the course on DSL, and that's one of the reasons why the textX exists, actually.
All right. And do you remember how you first got introduced to Python?
Well, I remember it was relatively late, since Python is around since 90s. I used different languages back there, and I even missed the opportunity to use Python in the days where I do a lot of sysadmin stuff, where Python is used a lot. I think I tried to pick up Python first in 2008. But I remember that I was put off by semantic white spaces at the time because I didn't have actually any experience with any language that did something like that. So I remember I cooled off a little bit and again tried Python. I think it was 2009. And I decided that time to give it a few days. Let's try it for a couple of days and see how the things will go. And I remember that day after day, I actually start to enjoy even the white space stuff. So the nesting with white space started to get very, very logical to me. And later on, I learned there is actually a name for that in a DSL literature. It's called the secondary syntax, part of the language syntax that does not have specific semantics, but you can freely use. That's the white space. For example, in textual language or in graphical language, that's colors and shapes and positions. And actually, if you have a lot of secondary syntax, you get all sorts of readability issues because people tend to develop their own styles. And Python did it quite good here because reducing secondary syntax actually improves readability. So yeah, I actually love it a lot now.
And then in terms of the context of domain-specific languages, can you give a bit of a description about what they are and some of the cases where you might need to build one versus just using a general-purpose programming language?
DSL is a language tailored and constrained to a particular domain. It is at the right level of abstraction, which enables its user, the domain experts, a higher level of expressiveness by removing unnecessary information that is a part of common understanding. What do I mean by that? For example, imagine two lawyers. If they're talking some legal issues, because they are operating in the same domain, they can remove all unnecessary information that are common understanding. So their expressiveness is higher. They can use shorter forms to convey information between each other. But if they are about to explain something to a person that is outside of the legal domain, they will have to be much more verbose because they do not share the common understanding. Besides using the concept of a domain, DSLs also use a concrete notation that is used in a given domain and thus, ideally, making the domain expert capable of specifying the solutions on their own. Of course, in practice, that is not always achieved, but anyway, even if the domain expert is not using the DSL directly, it is much easier to communicate with the developer when they're looking at the familiar notation for them. DSLs came in different forms and shapes. We have, for example, internal and external DSLs. Internal DSLs are those built inside the host language. For example, if you use some clever feature of some language, you can make something that looks like a different language, but is actually interpreted or compiled by the same compiler. Some languages are more capable in that direction. For example, Lisp is well known for being very capable when it comes to DSL, and the Lispers are usually create DSLs all the time. Then we have, for example, some of the more contemporary languages like Ruby is also very popular for building internal DSLs. Even Python, which is not very capable of building internal DSLs, we see internal DSLs all the time. For example, if we take Django as a web application framework, in Django you have the definition of a data model. You create a class that extends the model class, and then you specify some class attributes as an instance of a field. And then Django is capable from that description to dynamically generate all kind of stuff, like, for example, object relational mapper or SQL schema, or, for example, admin interface for CRUD operations. On the other hand, external DSLs are full-blown languages on their own. They have their own syntax. We have to build a compiler for them or interpreter, so they are much harder to build and maintain. And then, of course, we have other categorization, like, for example, by concrete syntax, we have textual or graphical or some other notation like tabular, or those languages are DSLs, but just with different interface to the user. And why we should use DSLs? Well, first of all, when you are constrained in a way what you can say, and you use only the domain concept, you can express the solution in a much more condensed form. So you're more expressive, because the commonly understood stuff is hidden from you. It's built into the tooling platform, into the compiler. That enables us to be more productive. Some case studies, for example, there is a case study by Meta case done in Nokia. I think it was like maybe 10 years ago, done with development of mobile applications. They measured productivity boost by a factor of 10. But in general, what I can observe in practice is that you should achieve at least a factor of 5 if you implement DSL in the right way. Another appealing reason for using DSLs, beside productivity boost, is that your solution, your knowledge from some domain is stored and specified in a DSL, which is independent from the underlying technology. So it will evolve not with the technology itself, but with the domain. What it means is that your knowledge is preserved and can be easily transferred to another target platform. And what is also important, because it is on the right level of abstraction that is familiar to the domain expert, the specification of a solution serves also as the up-to-date documentation of the system.
And so textX is a tool chain for being able to define your own DSLs for being able to incorporate into Python and other language projects. I'm wondering if you can give a bit more description about the textX project and some of the motivation behind creating it and some of its origin story.
Well, textX is actually a DSL and a tool for building DSLs. So it's a meta language. And the motivation was early in my career, I got introduced to model-driven engineering. And the DSL just, let's say, a different flavor of it, or they are overlap a lot. So I quickly got into DSL stuff through the project called Xtext. It is a Java-based project, and I think it was somewhere in 2005 or 6 when I played and used the Xtext. And I always wanted something that is similar to Xtext, but in Python. And I wanted something for the DSL course. So it should be lightweight, it should be something easy to use. And the Xtext was a little bit heavier because it is Java, it is Eclipse-based, and it is a lot harder to learn. So I wanted something easier for a student to get started. So that's the motivation. And I think I started developing it somewhere maybe 2005, I think. 2015, sorry. So that's the time I decided to sit down and actually implement it, because I realized there is nothing similar to it in the Python world at that time.
And as you mentioned, there are a number of other libraries that do exist in Python for being able to build DSLs or write parsers, but what are some of the capabilities of textX that make it stand out, that might cause somebody to choose it over some of the available other options, and maybe some of the characteristics of the overall space of DSLs in Python that make something like textX useful and necessary?
Yeah, there are great options in the Python world. We're actually lucky to have many parsing options. There is, for example, ply and sly and pyparsing and parsimonious and lark. Even Antler, for example, which is a Java tool, but can produce a parser for Python. But all those tools are, I would say, more like a normal parsing or classical parsing tools, where you get much more involvement into building. When you're building DSL, you have to, beside grammar, you have to describe the actions actually, which is used to transform the parse tree to something else, or they can do that on the fly without building parse tree. So you have to do a lot more to maintain your language. But the textX is built on the idea that stems right from xtext, where you actually describe, through the grammar, you actually describe both the parse or the syntax of the language and what we call the meta model of the language, or the structure of the language. So in a way, it is constrained. That's why I like to say it's DSL for building DSL. You're constrained, but through that constrainment, you actually are much more productive, and you can say more with less, because it's all you need is more or less the grammar itself, and you can start using your language. Text will, out of the box, create all the necessary elements of your language dynamically. So it will create classes that correlates with your grammar rules. It will create a parser that will parse your textual representation of your model and instantiate the object of your dynamically created classes. And that all happened at runtime just by reading the grammar. Your language is much easier to maintain.
And for people who are building these DSLs, how does the actual definition of the grammar end up hooking into the behavior? As you mentioned, with the direct parsing tools, you have to be much more manual and explicit about it.
Well, when you're using classical parsing, you make grammar, and then you will either get a parse tree or you will get some nested list, for example. That's one way to transform the parsed content to some data structure. But then you will need to transform that to some other form to be usable in the further processing. And you have all sorts of things like if that is some real language, you have, for example, a reference resolving, or you have to define, for example, parent-child relationship between elements. That's all built into textX. So by just giving the textX a grammar, you will get the nice graph of, you are not getting the parse tree, you are actually getting the object graph of plain Python objects, and they are connected by the reference resolving. So it's not a tree, it's a graph, and you can use it straight away. It's a graph of a Python object. And you can plug into the creation sort of way, you can define something called in textX object processors. So object processor is a callable in Python that is called to either check or transform the object that is being created. So in that way, you can implement additional semantics checks, or you can on the fly change the object being created. That is similar to, for example, semantic action you're doing in classical parsing. But this is optional thing that you can add to introduce additional semantics or additional transformation of the objects.
And so for those semantics, is that something like being able to say that this particular token is a keyword, whereas this other type of token is the beginning of a function definition or the end of a function definition and things like that?
Well, that will be actually given to you straight away, because if you're asking about tokenization of the input, the textX is based on peg parsing or peg grammars and recursive descent parsing called packet parsing. So it will distinguish between the name of, for example, of a function and some keyword because it has unlimited look ahead and can resolve that ambiguity.
For people who are defining the DSLs, what are some of the challenges that they face in just constructing the syntax of their target language? And what are some of the types of inspiration that they might look to for determining how it's going to look and the user experience of the people who are going to be using that language and the DSL parser and logic that are going to be generated and built with textX?
Well, there are all sorts of challenges during language design. First of all, we should be sure that when building domain-specific languages, first we must be ensure that the domain is covered correctly. What that means is that you built into your language the correct concepts and the relationship, and there are no concepts that you're left out, or that you don't have any additional concepts that are not relevant for the domain. What usually happens in practice and is a danger for DSL developer is that you start with a DSL for some domain, but then it's very tempting to add stuff to that language, and many times DSL end up being a GPL, a general purpose language. That's one consideration. The other is defining the proper syntax for the language. And when we are talking about DSL in general, we are not talking about only the textual languages. Concrete syntax can be anything, can be graphical representation, can be tabular. So the concrete syntax is actually the interface to the user, what user will see and feel and interact with during the usage of the language. So it must be very nice, it must be easy to use, it must be very intuitive. To be intuitive, it must already correlate to the existing language in the domain. We are just formalizing what users are already probably using. And those are considerations regarding the syntax. And of course, when we are building textual syntaxes, we have to consider all technical stuff like parsing issues, left recursion, ambiguities, and at the end comes the semantics. So we usually describe semantics by interpreting or compiling our language to something else. So choosing the right execution style, whether we should interpret our language or compile, makes a difference. And of course, it's probably less important, but we have to take care about runtime performance of our language. So all these decisions will influence how efficient our language will be in practice.
And on the point of runtime performance, what are some of the capabilities of Python that will lead someone to use it as the host language for a DSL? And what are some of the cases where somebody might want to use a DSL that's using a different host language that's more optimized for particular latencies or particular target environments?
Well, it depends how critical is the runtime performance for your use case. I usually look at two performances. One is runtime and one is development time or maintenance time. So if it's more important to you to quickly develop your language and to easily maintain it, then Python is a really good choice. Its dynamic nature gives you a quick turnaround and you can experiment easily. So no wonder it's used for prototyping and for things that are, write one and throw it away. So if your system really needs, it's critical and needs something that must give a better runtime performance, Python probably is not a good option. There are other languages that could serve as a better host. But still, you can use textX or similar tools built on Python to produce or generate code for some other runtime platforms. So you can see different aspects. What are you using for developing language and what are you using for runtime? Runtime can be different. So you can easily generate, for example, Rust code from using textX from your models. There is no any constraint in that regard.
And as far as the overall end user experience of working with the DSLs that are being built using textX, what are some of the associated needs as far as tooling or overall ecosystem of building and working in that environment? And what are some of the additional either associated projects of textX or capabilities built into it that help in that overall process?
Yes, well, tooling is very important when talking about DSLs. And given all the benefits you get from DSL, the main reason why people didn't use so much DSLs in the past probably is the tooling support, because it's not easy to build DSL from scratch and to maintaining. So there are actually a class of software tools that are specifically made for building DSLs, and they are called language workbenches. textX is not a language workbench, so it's a simpler tool. Language workbench is a integrated environment for building languages and evolving languages, so it's much more complex. But for the DSL part, there is a textX command that you get when you install the library. So when you install your library in a Python environment, virtual environment, you get a textX command that can be used to compile your or to check your model or to visualize your model, for example, or meta model. So you can, for example, generate a nice diagram of your grammar. It is a class-like diagram that describes the structure of the language. Or you can use textX, for example, textX command to start a project, to make initial outline of the project. And there is another useful tools. For example, there is support for language server protocol and Visual Studio Code integration. It is a project textX LS that is worked on. Daniel Alero is working on it. He was working on a master thesis regarding language server protocol in textX based languages, and after his master thesis finished, he continued to work on that. And now we have a second version of that project that is very nicely developing. So anyone who want to try textX should check out that project. It is under the same organization, GitHub, like textX itself.
Yeah, being able to have that syntax highlighting and the language server support in the development environments will certainly reduce the burden of people who want to be able to take advantage of the DSL without just looking at a blank wall of text and not really having any indicators of what the different tokens are and what their meaning might be in relation to each other.
Definitely. It's first thing that should be done when you're producing a tooling for your language, syntax highlighting and code completion and code navigation. So you should help your user to easily navigate around and to get help from the environment. And the textXLS is a project exactly for that. Any language you develop using textX can automatically generate the Visual Studio Code integration for that language. So out of the box, you get syntax highlighting for your language, which you can further configure if you're not satisfied with the initial results. And it is planned to support all styles of IDE support, like navigation and completion, and so it's not still finished fully, but it's very usable at the moment and can be tried out.
Digging deeper into textX itself, can you talk through how it's implemented and some of the ways that the structure of the project and its overall goals have evolved since you first began working on it?
Well, it's built on top of a parser called Arpeggio. It's a parser. It's a PEG parser I started developing in 2009. It's probably first project, real project that I did in Python. So when I decided to write textX, I decided, okay, I will use PEG parsing, and because I knew Arpeggio very well, and I realized that I will probably need to tweak it along the way to support all the features I want to have in textX. I use it, and that was a good decision, I think, because along the way I did have to tune a few things in Arpeggio itself to help develop some textX features easier. So basically, Arpeggio is doing the parsing. textX is just a layer above Arpeggio. How it works is that there is, if you open the textX source, you will see that there is a a textX grammar language defined in arpeggio syntax. And when the grammar is parsed, there is a visitor that will build the meta model and another parser out of the grammar. That another parser is arpeggio parser for your new language. And the meta model is the object holding all the information about your language. So all the concepts, all the relationship, everything is contained in that object. And that meta model object is actually used as a entry point, API entry point for further parsing. You create the meta model and you say meta model dot parse model from file or model from string if you want to parse the file or to parse the string. And the arpeggio parser built dynamically for your language is accompanied with a visitor that will transform the parse tree to the object object graph of corresponding to your grammar. And that design didn't change much from the beginning. So the core design remained the same, but the language itself for the grammar evolved over time. It started as xtext language. My idea at the time was to just make an xtext implementation in Python, but actually it grew over time and add some additional shortcuts in the grammar language itself and some way to easier specify some stuff. For example, there is something called a repetition modifier in textX. When you want to match zero or more stuff or one or more stuff, you can attach a syntactic addition to the plus sign or to asterisk sign and say, okay, match zero or more elements or objects, but they should be separated by something. And you just add the separator. In a classical parsing, what will you do? You will have to do that manually. You will have to say match this and then comma and this zero or more time. But in textX, it's much shorter to write. There are also, for example, rule modifiers that doesn't exist in xtext, but do exist in textX. There is a relatively recent addition of unordered choice. Unordered choice is when you have a sequence of things that you want to match, and you say, okay, match those sequence in any order. The textX or beneath arpeggio will match all those elements, but in any order they are specified, which is very handy for some languages that define, for example, some keywords that can be written in any order. So more or less, that's about the design itself. So the core remained pretty much the same through all this time.
And for people who are using textX for building their own languages, you mentioned a little bit about the need for having the grammar definition and then being able to parse the written language of the end user and being able to generate the concrete model from that. But what is the overall end-to-end workflow of somebody who is defining a new language with textX and then being able to distribute it to end users for them to be able to actually make use of that and develop within it?
Well, the workflow can be different depending on how complex your DSL is. So you can start very simple, like you can define your language embedded in a Python module. You can just write a string with a little grammar, and then you can call one function that will transform that string to the meta model, and then you can use a meta model. So it's just a few lines of code if your language is very simple. But if you are developing something more complex, then you can build the whole language project, and there is now a support for that in an additional project called textX dev that can be installed together with textX either by using pip install textX with the dev as dependency or as an optional dependency, or you can directly install textX dev. When you install that project, it will add additional command to textX called start project. So it's similar to, for example, how Django would create a new project. So you type textX start project and you get initial project answer to several questions, and then the initial project is generated. In that project, you have a grammar file where you should go to define your grammar, and then the project has a registration already built in. So the project will be registered with the textX. It is done through the setup tools extension point mechanism. So languages can be extendable, can be actually there are like plugins for a textX in a way. So you can use textX to list languages. And the generators for the languages are also registered in the textX setup.py. So you can list generators also. So in that case, workflow is start the project, textX start project, and then create the grammar. Usually I tend to first open just a blank file and try to write some model in it. So how I would like to express some solution. And then I write that solution, that model. And then in parallel, I'll develop a grammar for that. And then I usually have a small unit test that I run constantly to see if everything works. Or I just use, for example, textX command line to check if grammar is okay. And then I iterate. I extend the model, add some new things in the model, and then I extend the grammar and see if everything parses. And when I end up with the syntax part, so I'm satisfied with how the model looks like and how the grammar looks like, then I design the semantics. I built a compiler for that, either using some template engine, or I made a little interpreter for the language. At the end of the process, you can pack that up, make a package of it, and release it on PyPI, for example. So the user can just install that language. And if the user would like to have IDE support, you can use textX LS to build a Visual Studio Code plugin with all the syntax highlighting and stuff. And then you can distribute your language through that plugin. So those are the options. And it's very flexible. You can use it either very simple, or you can use it like a full-blown language project.
For the languages that you're defining, that brings up an interesting thought as far as how you would provide things like unit test capabilities for the people who are writing the language to ensure that what they're building is going to parse properly or function as intended. And I'm curious what your experience has been as far as how frequently people will actually go that extra mile to build additional ecosystem tooling for their languages, and just the overall need for it, and some of the points at which it hits the tipping point of complexity where that's even necessary.
Well, it all depends who the end users are. If, for example, end user are people that are not that technically savvy, probably it's probably good investment to make a good tooling support. And for the testing, I think it's generally always good to write tests when you're developing your language. I usually cover all projects, open source projects that I work on with PyTest with a good coverage. I think it's very important beside the documentation. I generally feel more confident when doing some larger refactorings, changing the language. I want to be sure that the assumptions that I had before are not broken. So I think it's worthwhile to put some additional job in making proper testing.
And then as far as the specifics of the parsing implementation, I know you mentioned that you're using a peg parser with some customization of the grammar syntax, but what are some of the situations where a peg parser is unable to unambiguously process a defined grammar and concrete implementations of it, and you would be better served with a different parsing approach?
Well, peg parsers are really, really nice for its simplicity. It's kind of something you will probably end up with if you're trying to build the parser manually. You will probably go to recursive descent. It's easy to understand. So the peg parsers are really easy to debug, but they have this difference comparing to context-free grammars, that their order choice is ordered. So the alternative is ordered. And by that, I mean when you have several alternatives to match at some point, you're telling the parser, try this. If this does not succeed, try the other one. And do this until you find something that succeeds. So in a way, pegs are more imperative in comparison to context-free grammar, which are more declarative. You say, this non-terminal is this or this or this. I don't care in what order or whatever. It's just this. I declare this. And what's the problem with peg is that it will always be unambiguous. But this might sound good, but in practice is actually not always, because it hides the ambiguity in the language. It will just go from left to right and pick first that match from the ordered choice, and that is the way it resolves ambiguity. But it's not always what you want. So, and you will not get any warning. It's the grammar is very hard to analyze for those things. For example, the typical problem you have with pegs is, for example, imagine you try to match A, and then if that doesn't succeed, you will match A and then B. You can see that this second match will never succeed or never be reached. If you find A in the input, it will be matched by the first choice. So this A with B afterwards will never be reached. And then can introduce various problems in practice. And the most difficult problems are when you reorder the order choice. You are actually changing language, but it's hard to see how. So in a big grammars, that can be problematic. You don't have any analysis from the tool. And with the other parsing approaches, which are based on CFGs and do some pre-processing and grammar analysis, you do have some help, either through some, like, for example, shift-reduce conflicts that tell you that at some point you have some either ambiguity or you need more look ahead to resolve something. So pegs are easy to debug, easy to understand, but do have their own problems.
For people who are using textX and building their own languages, what are some of the common challenges that they run into, either in terms of being able to overcome those challenges of the limitations of the PEG grammar, or just the overall process of building the DSL and making it available to their end users for being able to do the work that the DSL is intended for?
So if I understood the question, usually people, from my experience, because the problem with open source projects is that you don't always get the full feedback from the users, but I do have a lot of feedback from my students. So it usually goes relatively smooth. When they have a good documentation and good examples, they will just read through that, and generally they understand that very, very well. So they don't have much problems with it. Usually, initially, they have sometimes they have a sort of fear from the parsing in general, probably because previously they were exposed to some old classic tools like Flex and Yak and similar. So they consider parsing very hard and hard to understand. But I think that fear is very quickly overcome when they start to work with easier to understand and to use tools.
And as far as projects that you have seen built with textX or that you've built yourself, what are some of the most interesting or innovative or unexpected ways that you've seen it used?
Again, the most projects I see developed are from my students. There are several projects listed on the textX front page who is using, but usually users don't reach out that much. So I encourage users of textX who are listening to this podcast to drop me a line what they're using textX for. I always like to hear about that. But from the other projects, probably most interesting was a project done by several students. It's a language for describing guitar tablatures. They call the project PyTabs. It's on the GitHub. And the guitar tablatures is a way to write the pieces of music done for guitar, but for folks that probably didn't have, for example, formal education, don't know to read notes. And it's a very easy to understand format. It actually depicts the neck of the guitar in ASCII art, where you see 6 strings running horizontally. And on each string, there is a number that says it's a fret you have to press when you play that note. And they managed to parse that with textX, and the grammar is actually very elegant. And if you think about it, it's like a two-dimensional language. You have not only you're not only parsing horizontally, but vertically also, because you have to correlate the different strings at the same place. And the interpreter for that language will play the music. So they designed the language with the semantics of playing the music that is described by the user. So it's, for example, for me, it was very innovative and interesting way of using textX.
Yeah, that's really cool. And as far as your experience of building textX and maintaining it and continuing to use it as a teaching tool, what have you found to be some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Well, maintenance of open source projects in general, I learned is time consuming and not very easy to do, especially when the projects start to get some traction. So when you're maintaining project, you have a lot of work to do around just organizing stuff, making sure every issue is commented on and every pull request is reviewed, and et cetera, et cetera. And the release process is done properly with right versioning and stuff like that. So since many open source projects are done on a voluntarily basis in a free time, and it's something hard to do. So I think it was a year and a half ago, I got a really great contribution for Pierre Burrell. It was implementation of custom scoping support, because textX had always this reference resolving thing, but reference is, let me quickly just describe what it is. For example, when you're parsing something, at some place you have, here I want to match the name of some object I defined somewhere else. And the textX in that place will resolve that to a proper Python reference. So you don't have to do that yourself. That's why you end up with a graph of Python object, not a tree. And the scoping was done by using a global scope. So the textX in an older version or by default will search for that kind of object, that type of object, but globally. And that's not what you always want. So Pierre done a support for custom scopes. You can define the custom scope provider that will where you can in Python define actual algorithm how that object is to be found. And another piece of that pull request was support for multi-model and multi-meta model. So you can, for example, have several grammars different, and you can build model that can reference things from other model in other languages. You can even reference things that are outside of textX. For example, you can reference specific node in a JSON file or a specific node in an XML file. And that support is really cool. And he did that a year and a half ago, sent a pull request, and we have really great collaboration on that pull request. And when we merged that to master, I asked Pierre to join the project to help me maintaining, and I'm really happy he accepted. So he is now co-maintaining project with me, and it's much easier when you have someone that is a co-maintainer with you, because we can discuss this design decision. And sometimes I don't have time to look at some pull request or some issue. Sometimes Pierre don't have time, so it's much easier when there are more people.
And one of the other interesting things that I found out while I was doing the research for this conversation is that in addition to textX and the arpeggio parser that it's using, you've also built another parser using a different type of grammar support called parglare. I'm wondering what your motivation was for creating that, and just some of the ways that your experience in arpeggio and textX fed into the work you did there, and some of the ways that the work you're doing on parglare has informed decisions about how you approach things within textX and arpeggio.
Well, it's actually started as problems in PEG parsing I realized at that time. So, for example, one of the problem I already said about it, it's that unambiguous parsing, which is not what you always want. There are hidden ambiguities. The other thing, for example, generally related to all top-down parser is they generally don't accept left recursion, left recursive rules. And sometimes grammar is most naturally described by using left recursive rules. For example, if you're building something that is heavily expression oriented, it's much easier to encode it naturally for example, expression. If you're building expression for arithmetic operations, you can easily say expression is expression plus expression, or expression minus expression, and so on. With top-down parsing, you must avoid the left recursion, so you encode those rules differently, which is not very natural. So I wanted to experiment with the other parsing approach. My idea was to offer additional backend for textX. Instead of arpeggio, for example, as an option, you could plug in some other parser. So I built a parglayer to experiment with LR parsers, bottom-up parsers, and especially I was interested in general parsing. So the parglayer also implements GLR parsing. And later on, I realized that trying to put two different parsing styles in a textX project would be very complicated. So I decided not to do that, but the parglayer project itself was developing quite nicely, and I really liked some of the results I got with especially GLR parsing. So and I like the way you can use actually context-free grammars to declaratively express your language. Some learned lesson I get from the working on parglayer is that sometimes it's really nice to have something easy to start with, like peg parser, especially for students that are learning parsing. But sometimes you need more power like bottom-up parser with declarative specification of a language, and with full general parsing like GLR, which can accept any context-free grammar, even ambiguous one, and can, in case of ambiguity, can produce parse forest, so all the possible solution for your input. And that's especially, for example, important for natural language processing, where you by default have ambiguity in your language.
And then for people who are making the decision of what to use, what are the cases where textX is the wrong choice and they might be better served by either using a different DSL library or using a simple parsing library and then doing the manual resolution of how that logic is supposed to play, or just using a simple regex for maybe the smaller cases?
Well, if you're trying to parse something more complex, it's generally not a very wise choice to just use regexes. So generally, I recommend always use some parsing library, because even if you think you can easily handcraft your parser, there are all sorts of edge cases that are already built into the parsing library, and there is good error support and stuff like that. But handcrafting parser can give you additional control. So if you want a real total control over the parsing process, or, for example, if you want to learn parsing in depth, then you can go with handcraft parser. And for different libraries, well, textX is not a great choice if you really want to influence the outcome of your parsing. So if you want to have complete control over what are you transforming your input to, or, for example, if you want to get the best possible runtime performance, or, for example, if you want to parse a stream of tokens as they arrive, then textX is not suitable parser for that. Or, for example, if your input is ambiguous naturally, like, for example, it's a natural language or some language that is ambiguous, you cannot use peg parser in general for that in that case. So generally, if you need full control and you want to produce something that does not correspond fully to your grammar, let me give you an example. If you are building an expression-based language, for example, maybe you want to evaluate the expression on the fly. If you want that, then textX is not a good choice, because you will always end up with an object graph, and you will have to transform that graph to the result of the expression.
And as you continue working with textX and using it for your own purposes and for your teaching, what are some of the new capabilities or features or just overall improvements that you have planned for it, or associated projects that you have in mind to build?
Well, first of all, one thing we discussed recently was to drop Python 2 support from textX and Arpeggio. They're still compatible with Python 2, and because of that, we cannot move on with some Python 3 only stuff. For example, one of the things I would really like to see in textX is type hinting, so we can provide more stricter check for types in the library itself. And there is also one bigger feature we have been planning maybe a year ago. It is a small DSL for custom scoping providers. That is the part that Pierre was working on, but you now describe the scope providers by Python functions. And the idea was to create a small DSL where you can describe the scoping rule by very small and simple DSL, then you can embed in the grammar itself. So at the place of using a reference, you can write that expression that tell textX how to resolve the reference. And there is even, because we were discussing that on several issues, we made in the wikis, there is a tab 1 is textX enhancement proposal. So we collected all the idea about that DSL in that document. And that is probably something we should work on in some future when we find some time.
Well, for anybody who wants to get in touch with you or follow along with the work that you're doing or contribute to your work on textX and your other libraries, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And this week, I'm going to choose the project We Make Python Style Guide. It's a set of plugins for providing fairly strict linting of your projects, and I've started using that on some of the new projects I'm doing lately at my job, so been enjoying that. There are a few things that I've had to turn off, but all in all, it has been doing a good job of making sure to catch some of the silly errors that I add in as I'm working without me having to go through the whole, read, evaluate, print loop, just being able to see in my editor that a mistake was made and fix it in that context. So I've been enjoying that and recommend it to anybody who's starting a new project or wants to add some new linting rules for their work. And with that, I'll pass it to you, Igor.
Well, my pick would be something I rediscovered lately. It is called interactive fiction. It's a genre of crossover from literacy to the gaming. I remember I played those games back in the 19s, but at that time they were called text adventures. So recently I tried to see what happened with that genre. I thought it was completely gone. It was very popularized in the 80s by Infocom, I think the company was called. And it is, nowadays it's not visible, at least on the surface of the internet. So I dig deeper and find out that the community around interactive fiction is actually very alive. And there is a site, for example, called Interactive Fiction Database, where you can find titles that are published even in these years. There are authors actively working on new titles, and what is interesting, there are authoring tools that are actively developed. One is called TADS, and the other is called Inform 7, that is developed by Graham Nelson, a British mathematician. And Inform 7 is very interesting. It's a kind of DSL, but based on a natural language. So when you read the description of the game, it's like you're reading what you imagine would be when somebody would describe the language to you in a plain English. And here is a little quote from the Inform 7 website. It says it's a tool for writers intrigued by computing and computer programmers intrigued by writing. Perhaps these are not so very different pursuits in their rewards and pleasures. So it's very interesting. So I encourage anyone with interest in reading novels and solving puzzles to try out interactive fiction.
Yeah, there's another category of that as well with multi-user interactive fiction. Mm-hmm. And I did an interview with the maintainer of a library called Ivenia a while ago. So I'll add a link to that in the show notes as well.
Oh, that sounds great.
So with that, I would like to thank you for taking the time today to join me and discuss the work that you've been doing with textX and Arpeggio and Parglare. Definitely a very interesting problem domain and something that can provide a lot of utility to people who are struggling with trying to build their own DSLs or make Python work the way that they want it to syntactically. So I appreciate all the time and effort you've put into that, and I hope you enjoy the rest of your day.
It was my pleasure.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.